moving on to Unit 2.2, Guided Notes. We're going to look at multi-step equations that have variables on both sides of the equal sign. How do we deal with that? We know we need to isolate the variable, but what if they're on two sides of the equal sign? Well, of course there's a way to deal with that. One, again, you start by distributing if necessary. You know it's necessary because there are parentheses. Two, you combine your like terms. So we're going to add a step. We're going to add a step. After combine like terms, your step 3 is going to be move variable left. Can you move the variables to the right? Yes. Why would you want to? Move them left. If you find a problem where it just makes sense to move the variables to the right, then do it. You'll still get the same answer. I'll show you. And then 4, solve. All right? So, step 1, distribute if necessary, not necessary. Step 2, combine like terms. When they say combine like terms, you have to stay on one side of the equal sign or the other. You can't combine across because they're different values, right? They're in different locations, right? Think of this like the state line. You can be on this side of the state line or this side of the state line, but the laws are going to be different on each side of the line, right? So, because there's no like terms on this side of the equation, and there's no like terms on this side of the equation, that step is done. We can skip it. The next step is to move the variable to the left. In order to move the variable, we take the term with the variable and we use its inverse and move the whole thing. We literally move the whole thing. Right now, this is a positive 3y. Inverse of positive 3, the opposite of positive 3 is negative 3y. Right? What you do to one side, you have to do to the other. We're literally picking it up and moving it over here. But in doing so, we had to change the sign because to get this to zero out, you have to use the inverse. Right? 5y minus 3y is 2y. Bring down everything else. And now it's just a basic two-step equation. Right? Get rid of the constant. 2y equals 20. Isolate the variable. Y equals 10. Again, if it starts with a variable, 99% of the time it's going to end with a variable. Now I told you I'd work it both ways. So instead of moving the variable left, this time I'm going to move it right. So 5y minus 8 equals 3y plus 12. So this time I'm going to do the inverse of positive 5y, which is negative 5y. Thank you.
You don't have a flag? Okay. Mr. Mack.
Sorry for the interruption. Alright, so inverse is negative 5y. So negative 8 equals negative 2y plus 12. Because the variable is on the right, we're going to get rid of the constant on the right. Negative 12. This is negative 20 equals 2y. Divide by negative 2. 10 equals y, or y equals 10. Symmetric property says that I can flip it around. It's the same equation. I can either move the variable left, which makes the most sense in my head because it looks like what I'm used to, or I can move the variable right. And sometimes it makes sense to move the variable to the right because, well, in this case we ended up with a positive variable, and in this case we ended up with a negative variable, and some people don't want to play with negative variables. So do whichever makes sense. Most often it's going to make sense to move it to the left. All right, and then no parentheses, no like terms to combine. I'm going to move my variable left. So it's a negative 8x. So to move the whole term, I need to use its opposite. So I'm going to add 8x to both sides. Negative 6x plus 8x is positive 2x. Plus 14 equals 12. Get rid of the constant using its inverse. 2x equals negative 2 because 12 minus 14 is negative 2. Get rid of the coefficient using its inverse. Good. All right. No parentheses, no like terms. I'm going to get rid of that term, the positive 3k, by moving it to the other side of the equal sign. 4k equals negative 36. Don't lose your negative sign, it changes your answer. K equals negative 9. 36 divided by 4 is 9 because 9 times 4 is 36. Use what you know to figure out what you don't know. Remember fact family, right? 3 times 4 is 12. 4 times 3 is 12, right? We just learned that when it comes to multiplication, the order doesn't matter, right? Commutative property, right? But the opposite side of that, their inverses, is that 12 divided by 4 is 3, and 12 divided by 3 is 4. This is a fact family. These three numbers are like connected in ways you can't even begin to imagine. This is the inverse of this. So if you know this, then you know this. If you know one of these equations, then you should know all four of these equations. They're called a fact family. They're all connected, right? 4, no parentheses, no like terms. See, in this case, if I bring this over here, I'm going to end up with negative 11u. So let's go the other way. Let's go the other way. Add 2u to both sides. 12 equals 11u plus 45. So I don't have to deal with the negative variable. Negatives aren't the easiest thing to deal with, right? Get rid of, but see, no matter what, I'm going to end up with a negative over here then. So it doesn't matter which direction you go. Whichever one makes more sense to your head. Right? So subtract 10 would be negative 35. Subtract 2 more would be negative 33. Isolate the variable. U equals negative 33. U equals negative 33. Left or right, doesn't matter. You have to get all the variables on one side or the other. I keep saying go left because, well, that's just the side that makes the most sense to my brain. Probably to your brain too. Alright? Nothing to distribute, nothing to combine. Right now, apparently, we're just practicing moving our variables to the left or right, right? So this is a negative 1m. Don't forget the invisible 1. Let's move our variables left. So 11 plus 5m equals 51. Minus 11. Remember, if there's no sign, you can assume it's positive. So the inverse would be negative. 5m equals 40. Isolate the variable by dividing by its inverse. M should equal 8. One more, I think. Yep. Let's do positive 7k over here, which is positive 7k over here. You're left with negative 3k plus 1 equals 40. Get rid of the constant term. Negative 3k. Be careful not to lose your negative. Take it with you. 39. Get rid of the coefficients. K equals negative 13. Don't lose the negative sign. If you lose the negative sign here, then you won't understand that the negative sign over here, and then you would end up with positive 13, and that's the wrong answer. It's actually the exact opposite of the right answer. Right? So think about it, look it over, ask questions, glue it in. Move on to the practice sheet.